In this video, we're going to investigate a bit further what is happening to consumption as prices change. So when you think about a downward sloping demand curve, we intuitively know that as prices increase, we will buy less. But people rarely stop to think about why you buy less as prices go up. And there's really two different components to that change in your consumption. One is that as the price of one good goes up, it is now more expensive relative to alternative products. So you might consume less as you increase consumption of a substitute. We call this the substitution effect because it refers to your change in consumption that results from the change in relative prices due to a change in the price of one product. But even if you only purchased one good, if there were no substitutes, you would still buy less as the price increased. And that's because as prices increase, the relative purchasing power of our income decreases. So if we have an increase in the price of one product, we would expect to see a shift in consumption away from that product and towards substitutes. But we would also expect to see a decrease in consumption across all products as our real purchasing power declines when prices go up. And we call that second part the income effect, the change in consumption due to a change in real purchasing power. So what we're going to try to do is to separate out these two effects and measure their size in response to a change in the price of a product. And this is called a Slutsky Decomposition. We have this identity here, which is really quite simple. It just says that the total effect on consumption has to be equal to the effect of the change in income and the effect in the change of relative prices. The income effect plus the substitution effect will equal the total effect on consumption. So let's go through a numerical example here to see how we can separate out these two effects in our model of consumer choice. So I've given you here demand equations for good X and Y, as well as some information about budget and original prices. First thing we want to do is just figure out what the consumer is doing before the price change. Then we'll look at what the consumer does after the price change, and we'll find a middle point to help us separate out our substitution and income effects. To find the optimal consumption bundle at the original prices, we are going to just plug in our values for income and prices to our demand equation. So this is pretty easy here. We've got 80 over 4 times 250, which is 80 over 10. So we'll choose to consume 8 units of X. And for Y, that's going to be 80 times 3 over 4 times 10. So 240 over 40 gives me 6 units of Y. So now, on our graph, the graph here is really important, so you want to be really careful when you're putting your budget constraint and your indifference curves onto your graph. Notice that we're going to be using a decrease in the price of Y, so I want to leave some room on the Y-axis for that budget line to shift up as prices change. So as I find the intercept of my budget constraint on the Y-axis, I'll take income divided by the price of Y. That's 80 divided by 10, or 8. And I'm going to put that here just to give myself room for the budget constraint, again, to shift up as the price of y decreases. And then for my x-intercept, I'll take 80 divided by 250, which gives me 32. I don't need to worry about this shifting, so I'm just going to put that all the way over on the x-axis. Now that I've got my budget constraint, I'm going to put my original consumption point on the graph. I'll consume 8x and 6y. Then I'm just going to sketch my indifference curve sort of lightly on here so that I have some idea about what's going on with my utility function. Okay, so now what we want to do is show the effect of this change in the price of y. So you can see in part B, the price of y decreases. And I'm going to, again, just plug that into my demand equations to get my optimal choice of x and y. Notice that there's no change in x because demand for x is not a function of py. And that's specific to Cobb-Douglas, but that's going to be true for any Cobb-Douglas utility function. Demand for y, likewise, is not a function of the price of x. All right, so y is going to be 80 over 4 times 6 now, which gives me 80 times 3, that's 240 over 24, which gives me an optimal consumption of 10. Now you can see the total effect of this price change is no change in x and an increase in consumption of 4 units in y. I'm going to draw my new budget constraint on the graph. The intercept for x will remain the same because the price of x has not changed, but the intercept for y will increase. So I'll take 80 divided by 6 to get that intercept, and that's going to give me something like 13 1/3. So I've got, say this is 10, 12, 13, something like this. Now I'll put my new budget constraint on the graph, and I'm going to use a different color. I want to keep this separate from my original budget constraint. So it's going to be something like this. And my new consumption bundle will be 8x and 10y. Just over here. And again, there's some indifference curve that is tangent at that point. Of course, I'm going to be on a higher indifference curve here. My utility will increase because prices went down. I get to consume more. That makes me happier. All right, so now what we want to do is to think more about how we can separate out our income and substitution effects. Remember that the income effect comes from a change in real purchasing power. So what we want to do is to hold purchasing power constant and just look at the change in relative prices. To do that, what we're going to find is the income level that allows me to still purchase my old consumption bundle, my original consumption bundle, at the new prices. All right, so I want to find the income, and I'm going to say this is IC for compensated income. I'm going to find the income that allows me to purchase my original consumption bundle at the new prices. So the price of X hasn't changed, but the price of Y has. I want to purchase 8X and 6Y. Okay, original consumption bundle, but new prices. And what this is going to do is it's going to hold my purchasing power constant and just look at the effect of the price change so that I can calculate how much of my change in consumption is due to the substitution effect. All right, so if you plug that in your calculator, you get income is equal to 56. So to calculate the substitution effect, I'm going to find the consumption point with the compensated income holding purchasing power constant, but the new prices. We want to use our compensated income and our new prices to find our optimal choice for X and Y. So I've got an income now of 56 divided by 4 times 250, which will be 5.6. And for Y, I've got 56 divided by 4 times 6, which is equal to 7. On the graph here, what's happening is I have a new budget constraint with the new prices and this compensated income. So I'm going to shift this line down, right? This one has the same prices as my new budget constraint, so it should be parallel to this. But I'm going to shift this line down so that it passes through my old consumption bundle. Something like that. Where note that these two budget constraints are parallel. They have the same prices, but different incomes. So by using this new compensated budget constraint, it has the same prices as the new prices, but the same purchasing power as the original bundle. So now I'm going to just label my original bundle here. I probably should have done this from the beginning, but my original bundle I'm going to call point A, because we did it in problem A. And my new one I'm going to call B. And what we're going to do is now find the optimal choice, the optimal consumption bundle for along this compensated budget constraint, right? That's what we found here. Y equals 7, X equals 5.6. And that's going to give me this point here, point C, to help me separate out the income and substitution effects. So you can see that as we hold purchasing power constant but change prices, that's my substitution effect, right? I decrease consumption of X and increase consumption of Y, right? That makes sense. As Y gets cheaper, I'm going to substitute by consuming less X and more Y. I'm going to write that down, right? Substitution effect is where I hold income constant, okay, or purchasing power constant, and change prices. And I can see that my consumption of X has dropped from 8 to 5.6. So it's fallen by 2.5 almost units. My consumption of Y has increased from 6 to 7, so it increased 1 unit. And then as I move from point C to point B, you'll notice these lines are parallel. In other words, the prices are the same. The only difference is a change in income, a change in our real purchasing power. So as I move from C to B, this change represents the income effect, which holds prices constant and changes only income or real purchasing power. So if I look now here, right, this is point C, B, A. What I'm doing here is now moving from 7 units of Y to 10 units of Y. So Y increases by 3 units. X increases back to 8. So that's positive 2.4. And if I sum these all together, you can see the total effect, and it's 0 for X and 4 for Y, the same as, you know, what we calculated in the first place. So what I've done here is I've found this point C, which represents the point at which the old bundle would be affordable, holding purchasing power constant, but using my new prices. And then by examining the change in consumption between the original point, my compensated point, and my new point, I can separate out the impact of my income and substitution effects on the consumption of both goods. Now you'll notice here that consumption of X has not changed. This is unique to Cobb-Douglas because remember, for Cobb-Douglas, we have, we hold constant the share of income we spend on each good so that demand for X does not depend on the price of Y. And so this is unique to this utility function, the fact that here my substitution and income effects are canceling out for the good where prices did not change. My income effect tells me something about whether the good is normal or inferior, right? Here we have 2 normal goods. And my substitution effect tells me about the relationship between those goods. Here they are substitutes. As I consume more of one, I consume less of the other. And so this decomposition is helpful for us to think about the characteristics of these products and think more deeply about the effect of price changes on consumption.